Hello guys, it's me again, your teacher Miss Cab. So what I have just said, we will have to continue our discussion about particle of matter. So today we will have more activities to perform, answer, and analyze some questions. So are you ready? Right. Before we proceed, if you are new to this channel, don't forget to subscribe, like, and hit the notification bell for more updates in our science class. Okay, try to look at this video, guys. This is our activity number 4. You observe that the volume of water from an open container decreased after leaving it overnight or for how many days. So how do we explain this? And where did the water go? So based on the particle model of matter, particles are always in motion. Note that the particles mentioned in this case are the molecules of water. So these molecules have kinetic energies that differ from each other. Some particles are moving faster than others and therefore have higher kinetic energy, and some are moving slower. So even at room temperature, some molecules of water have enough kinetic energy to overcome the attraction of neighboring molecules and escape from the surface of the liquid and eventually move into the air. So try to look at this video, guys. And to break away from the surface of the liquid, the molecules must have at least some minimum of kinetic energy. The process by which the molecules on the surface of a liquid break away and change into gas is called what? Is called evaporation. Correct. So, what is evaporation again? This is the process by which the molecules in the surface of a liquid break away and change into gas. So, as evaporation takes place, the water molecules uh, which did not escape and were left in the liquid have a lower average kinetic energy than the molecules that escaped. So the effect of this is the decrease in the temperature of the liquid water. So guys, evaporation is a cooling process. So you can feel this effect yourself when you apply acetone on your nails or rubbing alcohol on your arms. So acetone and rubbing alcohol are volatile liquids. So meaning they readily evaporate. So as they evaporate, the molecules get heat energy from your body, leaving you with a cool sensation. So it is important to remember that evaporation of a liquid in a closed container is different from evaporation from an open container. So in a closed container, guys, no particles can escape into the air outside the cover of the container. So you may also have observed that there are droplets of water formed under the cover of the container. So evaporation still happens in a covered container. Some of the molecules of water on the surface of the liquid escaped and go into the gaseous state. These molecules may then collide with the inner surface of the cover, and as more of these molecules do so. So some may stay on the cover, accumulate and form droplets. And this process where a gas change into a liquid is called condensation. So it is reverse of evaporation. Again, condensation is the process where a gas change into a liquid state. So guys, in a closed container, the molecules of water continue to evaporate and condense, but there is no net change in the number of molecules in the liquid or in the gas phase, because molecules of water that previously evaporated are condensing, but other water molecules are evaporating. There are many other examples of condensation that you may have observed. Just like, for example, condensation is responsible for the ground level fog that we see on some cold days. Now, example, when you are visiting some places like Don Salvador Benedicto, Baguio, or anywhere that you can see fog in the early morning. No? So that is one of the example of condensation. Another one example is uh, your eyeglasses fogging up when you go from an air-conditioned room or vehicle, or when wearing a mask and go outdoors on a hot day. This is because when warm air hits a cool surface, the condensation can form. And when your warm, moist breath escapes through the top of your mask, so and then it hits the lenses of your glasses, then that causes them to fog up. Another one example is, yes, the water that collects outside of your glass of cold drink. So that is one example of condensation. Okay, so that's it. In the next activity, you will represent ideas through a written description, a cartoon, or simply an illustration, and explain the changes taking place when water is heated or cooled using the particle model of matter. Okay, so in this activity, or in this is our activity number 5, and this is the activity that I had assigned you yesterday, right? So you are going to boil a 200 ml of water. Okay, kindly watch this video, guys. Yan. Okay, so what happened to the water? Okay, so you observe that boiling water for some time, the amount of water inside decreased. So as the water is heated and the temperature of the water rises, the molecules gain more what? More kinetic energy, and they move faster. So more molecules therefore have the energy to overcome the forces of attraction of the adjacent molecules. And these molecules escapes to the what phase? Gaseous phase. And this is what you call evaporation, no? From liquid to gas. That is evaporation. This evaporation and formation of gas can happen even below the surface of the liquid. So when this happens, ano ang nag-form? Right, the bubbles are formed. rise to the surface and escape into the air. So this is the bubbling phenomenon that you see when water boils. Okay, next. And in the part B of our activity number 5, part B, you were assigned to observe what changes takes place when water is cooled. Kindly watch this video, guys. First. Right, okay. So what did you observe? So you observe that as the water began to cool, droplets formed under the cover of the glass containing hot water. So where did these droplets come from? Yes, the molecules that escape from the liquid and go into the gaseous phase is called what? Vapor. And in this case, this is what you call the water vapor. The water vapor rises and some molecules touch the glass. The glass is cooler than the boiling water, so some of the heat energy of the vapor molecules are transferred to the glass, in effect, cooling the water vapor. So when a gas is cooled, the motion of the particles slows down. So if the particles lose enough energy, so their attraction for each other can overcome their motion and cause them to associate with one another to become liquid again. So this is the liquid observed under the cover in our activity or in your activity. And this process is called what? Correct. This process is called condensation. So just recall the two aspects of the particle model of matter. Particles are moving all the time and there are forces that act between the particles. And these principles can explain at the submicroscopic level of what you observe in this activity. Okay, next. So guys, not all of the water changed from liquid to vapor, right? So there was still liquid water left in the glass. Some of the molecules do not have the energy to overcome the forces of attraction of the neighboring molecules. So in addition, some of the molecules of water that escape to the vapor phase so hit the molecules on the surface of the liquid, and if they do not have sufficient energy, so the attraction of molecules on the surface cause them to stay and join the liquid phase. Okay, now so we are through with our activity number 5. So now let's proceed to activity number 6, which is entitled What Changes Takes Place When Ice Turns into Liquid Water? So the objectives for this activity is to represent through drawings or cartoons what happens to the particles of ice when it turns to liquid. So this time you are going to represent again or to draw again na what happens to the particles of ice when it turns to liquid. And second, you are going to explain the processes taking place using the particle model of matter. So try to observe what happens to the ice cubes. So naka-time lapse to guys. So this is 15 to 20 minutes. So try to watch this video again. Okay, so what happened to the ice cubes? So question number 1, explain what is happening to the particles of water in ice as it turns to liquid using the particle of matter. Number 2 question is explain what will happen to the liquid on the glass if it is transferred into small container and left inside the freezer after a few hours or overnight. So those are the 2 questions that you are going to answer. Again, number 1, explain what is happening to the particles of water in ice as it turns to liquid using the particle model of matter. And second, you are going to explain what will happen to the liquid on the glass if it is transferred into small container and left inside the freezer after a few hours or overnight. Okay, so I know that you already have your answer for those 2 questions. So in our activity number 6, you observe that after about 15 to 20 minutes, the ice cubes or the solid water turned into liquid water. The ice cube which was taken from the freezer is at lower temperature than the surrounding room temperature. So some of the heat energy of the surroundings is transferred to the water molecules in the ice. So this increases the kinetic energy of the molecules, and as the heat transfers continues, the particles gain more and more kinetic. The molecules vibrate faster and faster and at some point have enough energy to overcome the forces that hold them in their fixed places in the solid. So since the molecules vibrate so fast, so they break away from their fixed positions. The arrangement of the water molecules in ice gradually becomes disorganized, and the solid where the molecules are in fixed positions turns to liquid where the molecules are more free to move. Okay, so what you call this transformation? So this transformation process in which a solid is changed to liquid is called what? Called melting. Okay, so what is melting again? It is the process in which a solid is changed to liquid. So now it's your time to give another examples of this process. Give at least 5. Okay, next. On the other hand, when you put liquid water inside a freezer, the cooling system of that refrigerator removes the heat energy from water molecules, as a result of which they have less kinetic energy and move more slowly. So as more and more heat is removed and as the molecules move more slowly, meaning the forces of attraction between the molecules cause the molecules to be aligned. So as this removal of heat continues, the molecules lose so much energy that they are not able to move from place to place, but only able to vibrate in place. So this time, nasa solid state na siya. So in time, the liquid water becomes solid water, which is ice. So freezing is the process in which a liquid is changed to a solid. Again, so what you call that process? Okay, freezing. Wherein this is the process in which a liquid is changed to a solid. So note that liquid water that freezes is still water. Similarly, ice that melts is still water. This is why after melting an ice cube, you can freeze the liquid water back to ice. So in other words, the same molecules of water are involved when these changes occur. Okay, so in our activities from activity number 1 to 6, you have learned the 4 basic aspects of the particle model of matter. Okay, so did you still remember those 4 basic aspects of the particle model of matter? Right. Okay, so these are number 1, matter is made up of very small particles. Second, matter is made up of particles that are constantly moving. Number 3, there is an empty space between the particles. And number 4, there are forces that act between the particles. So using this model, using this model, you were able to infer the what you call that the arrangement and motion of the particles of matter, as well as the attraction between them, not between their changes when they change from one state to another. So, however, same particles of matter are involved when these changes happen. And the particle model of matter can explain the following phases of changes: the evaporation, the boiling, the condensation, the melting, and freezing. Okay, so those are the different changes, or the different phase change. Okay, so that's the end of our lesson for today, and that's the end of our first module in our third quarter. So, do you have any clarifications or questions? So, do not hesitate to put it in our comment box, or you can actually direct message me through our messenger or our Google Classroom. Okay, so that's all for today. See you next meeting, guys. We will talk about atoms inside and out for our next meeting, or in our next meeting. So see you in the next video. God bless everyone and keep safe. Bye bye.